Okay. So if anyone has live questions, feel free to raise your hands. And now I will read questions from the Slack channel. So the first question from Vic. Great work. I'm curious how hard to change the system using original RDMA APIs to this new API. Or in other words, are there any principles or automatic ways to do this?
If I'm reading, can you hear me?
Yeah.
Yeah, that's good. If I understand the question correctly, I think she's asking, Vic is asking if how easy it is to write applications using traditional RDMA versus PRISM. In principle, there's two versions of this. There are some applications that are equally expressible with both one-sided RDMA as well as as well as PRISM. Then this includes stuff that does a lot of indirect reads. You could always issue them as multiple one-sided RDMA reads. But if using PRISM makes it faster because it takes fewer network round trips to issue the same operation. But then there's also another set that is not expressible via one-sided RDMA. And this includes the version checks that I was talking about in the transaction protocol in the talk. For example, the existing CAS primitive of RDMA, with the existing CAS, you can't really do version checks. You can only do a single equality swap. So there is some extra expressive power that you're getting with PRISM, but then it depends on the application of what kind of benefits you're actually getting.
Mm-hmm. Yeah. I see Tao raised his hand. So Tao, please.
Hi. Thanks for the talk first. It's very interesting work. My question is this. So as we all know, the performance problem at the NIC is already significant enough. We have this cache thrashing problem, which is well known. And I wonder, will more complicated operations like enhanced CAS and pointer dereferencing exaggerate or make the situation worse?
This is actually one of the things we were considering. We wanted good performance predictability, and it had to be feasible to implement at the NICs. And with enhanced CAS and one in like the PRISM primitive operations, I don't see them being that much of overhead, but then we do allow chaining that is composition of multiple levels of indirection or combining multiple PRISM primitives. And that's definitely, well, we don't really recommend, we didn't intend for chaining to allow like arbitrary like chains of operations. And we are also limited in what we support with chaining. We don't really support generalizable loops or branches. So, but it is something worth considering. It needs to be carefully really thought about if you're actually building applications. Yeah.
Got it. Thank you very much.
Mm-hmm. So we have another question on the Slack channel. What if we could generalize this to allow shipping of short functions to remote NICs rather than adding specific primitives? Do you have any insights on why the primitive approach might be better?
Right. There has been other work that has been trying to explore this direction, and they've been using either things like SmartNICs or FPGAs to allow custom one-sided logic to execute at the NIC. They're all valid approaches worth considering, but there's still deployment challenges that come with these approaches. For example, data center operators at Microsoft have found it difficult to coordinate configuration updates to SmartNICs, and vendors might not really want clients to allow they might really not want to allow clients to execute arbitrary code in the NIC. There's definitely challenges, but it's interesting. And our work of having fixed primitives really helps in that it's easier to deploy and it's probably feasible to implement on a regular RNIC.
Mm-hmm. Yeah, thanks. And there's a third question from Xu Hao. If multiple processes are using PRISM, first, will each process has a separate free list? And second, will each process raise and rise to separate memory regions?
I see. Well, for the free list for allocation, I think this is managed by the NIC, but I'll have to check. But does each process read and write to separate memory regions? This really depends on what kind of memory is registered to RDMA. So they can write to the same memory region or different memory regions. That's really like it just works like regular RDMA.
Mm-hmm. And we have a follow-up question also from Vic. For the implementation on SmartNIC, could you understand these new primitives as short functions registered on the new SmartNIC core?
For our prototype, yes. So we do have a SmartNIC prototype that does this, but we were careful. Our primitives could also be extended on different network stacks too. So whether it be software RDMA or hardware NIC ASIC.
Mm-hmm. Okay. And I think the fifth question from Toy is already answered live. So which is about the cache stretching on NICs. So with this, any questions that you want to ask live from the audience?
Thank you. Sowmya, can you, you are already on camera and audio. So we have at least one question in Slack. It's from Professor Natasha Crooks, and she says, this is a bit of a general question, but I'm curious, what were the main design constraints that you took into account when designing the new primitives and why?
So hi, Natasha. Hi, Jeff. Hi, everyone. So essentially, one of the first considerations we took in was that each of the primitives had to have compelling use cases for applications, but we also wanted them to be feasible to implement in a regular RDMA-capable NIC and have good performance predictability as well. So those were three of our main considerations, yeah.
Do you think there could be more, or did you sort of use up all the good ones?
Well, for the applications we studied, I think we landed on some interesting primitives, but there could definitely be other unexplored primitives. For example, you can have applications that want to access persistent memory through RDMA, and those would need a new set of primitives probably.
Sure.
Yeah, and for other applications as well.
Okay, it looks like we have a hand up from Eno. Go ahead, Eno.
Yeah, hi, Sowmya. I'm Eno from NUS. This is great work. And my question is, can we run this on a SmartNIC, and how it would compare to running a custom program on the SmartNIC?
That's a good question. Technically, we do have a prototype that we prototype these particular primitives on a SmartNIC. And in that case, it's actually no different from running any other program on the SmartNIC. But we took into consideration that these fixed set of primitives should be integratable into different kinds of network stacks and not just a SmartNIC.
I see. Yeah, thanks.
Let's see, we have one other attendee with a hand up. Let me go figure out. So that's, let's see, promote to panelist. I'm doing best I can for Hariharan, who I guess needs to come back in.
Yep, I'm here.
Okay, go ahead. We can hear you, we can't see you, but that's okay.
Okay, I'll just turn.
There you are.
Thanks. So I was just wondering, for the chained version as well as indirection, how is the user going to see any sort of error? Because you could have multiple steps of indirection, and then it becomes less user-friendly because the bug might be harder to see.
Right. So there's two questions, like failure detection and debugging. So for failure detection, for each of our PRISM primitives, if they have multiple RDMA operations in them, the failures propagate. So if the first RDMA read fails and an indirect read, the second read also won't succeed. So basically, the failures would propagate along the PRISM operation. The second is, how do you debug? The easiest way to debug would be that you could always issue whatever PRISM operation you had separately, especially if it's a chained operation. You can issue them separately and debug them on the client side before you actually package them into a chained PRISM primitive.
Okay, makes sense. Thank you.
Okay, well, I have one more question from myself. So I noticed that in you had the Bluefield prototype that wasn't that fast, but you explained why. And then you had a nice fast software prototype, which was really very fast, surprisingly good. And I'm wondering, is that good enough that you don't actually need the hardware RDMA support? When you actually run real applications, is the difference in a few microseconds of latency from implementing PRISM in hardware actually going to make a big difference?
That's a really good question. Well, it also depends on the application. There might be applications for which the number of I/O is enough that you're actually going to have the small latency difference actually starts mattering a little bit more.
But aside from micro benchmarks, today you don't have any of those.
Yeah, no, not really.
Yeah,
No.
okay.